Let us proceed with the next topic in the graphics. In the previous topic in the development, we had seen some objects where it was given that the object is having some hole, that is a square hole, and if we are to consider that particular square hole or circular hole which is perpendicular to axis, this will lead to the penetration of two different objects. Let us consider a simple problem. Say a square prism. Problem says that a square prism of side 40 millimeters, a square prism of side 40 millimeters is resting on its base, such that the sides of the base are equally inclined. The sides of the base are equally inclined to the vertical plane. It is penetrated by a triangular prism. It is penetrated by a triangular prism of side 30 millimeters, such that the axis of the triangular prism is parallel to VP. Axis of the triangular prism is parallel to VP and is bisecting the axis of the square prism. Face of the triangular prism, the rectangular face of the triangular prism, is parallel to VP and away from the observer. Draw three views showing the curves of penetration. Now in this typical problem, they had not given us the heights of the prism. So we will start with drawing the square prism, that is square in the top view, such that the sides of the square are equally inclined to VP, that is making 45 degrees with VP, and you can very well darken them. So the square prism has been drawn in the top view. Height of the prism is not given to us. Let us assume some height, say 70 or 80, because in penetration problem they may not give us the height. So I am taking it as 70 millimeters and drawing the front view of that square prism. As we have said that we will complete the construction and then we will proceed with the naming part. As three views has been asked, as we are asked to draw three views of this solid, we will follow the procedure of drawing some line perpendicular to XY. Draw some line perpendicular to XY and then through rotation, that where that particular line is intersecting XY, from that particular point of intersection, rotate the paths that we have drawn in the top view. Till the XY line itself. So we are required to rotate, in this case the three paths which we have got in the top view. So those three paths should be rotated so that we can obtain the side view of that particular square prism correctly. And as we perform the rotation in the side view, we will get the shape or the view which is similar to the front view itself. Now axis of that particular square prism is coinciding with the generator of that square prism. Now it is given that the triangular prism is interpenetrating it. That triangular prism is having side of 30 millimeters. So let us construct it separately. We will construct the triangular prism separately. That is, the triangle should be constructed of side 30 millimeters. That construction should be there on the answer sheet. So an equilateral triangle of side 30 millimeters, and we are required to even locate its axis position. So I am constructing a triangle of side 30. So the triangle is constructed. Take the midpoints of two of its sides and join them to the opposite corner. To get the axis position, and so this is how we will obtain the axis. Once we obtain the axis, then this particular triangular prism is cutting the square prism. Now we will have to visualize a bit over here, and that visualization will actually say that it's a square prism, say like this. A square prism which is going to get cut by some triangular prism. So it will be cut like this. This will be going inside the prism and will be coming outside from the other side. Some shape like this is going to be there, and it is said that the axis of the triangular prism is parallel to VP, so VP is bound to be behind. And when you go for the left hand side view, if you look from left hand side, then the view is likely to be a triangle which is drawn in the side view, and it is going to appear something like this. This is how the triangular prism will have its one face, rectangular face, parallel to VP. And so we are required to first of all match the axis of this triangle with axis of the square, and so we have already constructed the triangle separately, and our aim is to mark that triangle in the side view. Axis is to be bisecting, so we first of all mark the center, and then we take the distance or the radius equal to the circumscribing circle as such, and then we'll draw that circle. The full circle is not actually essential, but as a construction you can always draw it, and then you can locate one point of that triangular prism, and then using the distance equal to 30 in the compass, it is possible that we can get the other 2 points of that triangle, and so the triangular prism will be now drawn in the side view. As we draw the circumscribing circle, we will straight away measure the angle of 30 degrees to mark that triangular prism, that is the triangle in the side view. which is going to be the equilateral triangle of side 30. The construction, that is the circle, can now be eliminated. And axis of this triangular prism is bisecting the axis of the square prism. So in the side view, we get the triangular prism correctly. And then we can complete the side view by darkening the remaining generators of this square prism. We are still in the construction phase. There is no naming for the points right now. So I have completed the side view of the particular problem. The side view which shows the triangular prism with its surface, rectangular surface, parallel to VP, because in the side view this vertical line will appear as VP. Now the naming part. Let us name the square prism as, say, ABCD, so that we know which generator is under consideration. So in elevation these will be the points A dash, B dash and D dash, C dash, whereas in the side view the central generator will be A dash and C dash, the rightmost will be B dash and the leftmost will be D dash. For the triangle, let us name it as P dash, Q dash and R dash, which are to be marked in the top view. So we will be simply drawing the projectors. We will be simply drawing the projectors in the side view and paths to obtain those points in the front view. Path is a line parallel to XY. And to get these paths in the top view, we are required to rotate these points. The projectors that we have got, those are to be rotated. So from side view now we are moving towards the top view. Earlier we had moved from top view to the side view. And then we get the generators. Corresponding to points PQ as well as point R. Now the length is not given to us, so I am assuming the length to be 10 millimeters more on each side, that is outside the square prism, and trying to complete the triangular prism's triangular face in the front view, and the same thing can be now taken down, and in the top view the triangular prism's triangular face can be marked. Now in top view I can show these generators, like this was the generator for P and R, up to the square and then going inside the square and coming out from the outside, the other side. And similarly the generator for Q can be shown dark up to the square and then coming out from the other side, and in between it is passing through the square prism. Though we have the construction lines over there, actually we will have to show it as the hidden generator which is present, because it is a square prism which is going to get penetrated, so its generators will be cut, whereas the generators of the triangular prism, they will remain intact. So these are the dotted lines which I am drawing over here, corresponding to the generator. This is generator Q, and these two, this line actually represents two generators P and R. Similarly in the front view, as we proceed to name the points in the front view, this is going to be the point corresponding to P dash. This will be, central one will be Q dash and the top one will be R dash. and we are quite sure that they will be full up to the square prism, but inside the points are going to be different, and that's where exactly the penetration or the curves of the penetration come into picture. To mark these points, see the procedure. In the top view, generator Q enters the face BC at this point, so we can take that point up and locate the point on generator Q. Similarly, the point on face AB where the generator Q is entering in the square prism through face AB, that point can be located, and we can straight away say that as we are going to look from the front view for the front view in first angle, this particular is the direction of viewing, and so generator Q is towards us, it will be visible, and you can see that the generator Q is fully present till this point, and it comes out of square prism from the other side, and in between it is not visible, so that will be dotted in the front view. Also observe that generator B of the square prism is not cut, so that will be full. This much portion of the front view can now be drawn. Once this part is drawn, then we can proceed with marking the points for generators P and R in the same manner. Like AD is cut at this point by generator P as well as R, and CD is cut at this point, so we can locate those points on the respective generators, point on P, point on R, similarly point on P and point on R. But another interesting thing is, if you observe side view, generators A dash and C dash are cut at these 2 points. So generator AC is going to get cut, and A dash and C dash are the extreme generators in the front view. So let us mark those points in the front view just by drawing the paths. So draw path from the first point and draw path from the second point also. So these are the 2 paths where generator C is entering or is cut actually. So generator C is present only up to this level, and this is the remaining portion of generator C. Same is the case with generator A, is present only up to this level, and from this point onwards. Top face obviously is intact, bottom face of that square prism is also intact. And now regarding the visibility, what happens is, as we are looking from front, face BC will be seen fully. So from point B to point C, everything will be visible, and if you look for the front view in the side view direction, because front view is obtainable by looking from the down direction in this direction, as well as you can look at the front view in this direction also, and you will find that QR face is visible and PQ face is also visible. So all the points which belong to these planes, those should be shown by dark lines, and so ultimately we are required to darken the points corresponding to face BC. So this was one point on face BC, and these are the remaining 2 points up to generator C. So this portion can now be darkened, and similarly the portion on the other side. It's going to be a symmetric thing. Once we draw this part in the front view, then we are required to even consider as what happens to the other points which we have marked. Those are on the behind surface and will not be seen from the front view direction, and hence we are required to show the corresponding sides because it is plane to plane intersection, those will result in lines, are to be shown by dotted lines. So these will be shown by the dotted lines. And remember, it's a vertical plane that is cutting another vertical plane. There is bound to be an edge which is getting formed. The curve of penetration is always going to be a closed curve. This is how it will be shown. And now observe that generator P will be visible. Actually it is present through and through, but it is visible up to generator A and C. You can observe it in the top view that it is present fully, but up to generator A, it will be visible from the front view direction, whereas this much portion is going behind, and that will be shown by the dotted line. Of course, generator P is intact. Square prism is getting penetrated by triangular prism. So all the generators of triangular prism, they will be intact, and so will be shown by the dotted line fully. And similarly, the generator R, it will be present up to generator C fully, and then it will be shown by the dotted line because it is present but not visible. And so we have shown the curves of penetration also in this case, which is our front view. And this is how the things will appear when the triangular prism is penetrating the square prism. If we just have a look at our imagination, then we have not failed on the imagination. There is going to be some curve like this that we had understood earlier also, and even some curve over here, and some portion is going from behind. If you look at the square prism from the back side, then probably you can see that it will be appearing as, say, a square prism from the back side. If you observe, then you will find that one face is entering into it like this and coming out from the other side, and this much portion of the face is inside. This is how the view from the back side will be. Whereas view from the front side we have already shown, that is through imagination, but we cannot exactly imagine as which points are to be located, and so we are completing the projections in this manner. It will be all the three views are drawn, and the two views are helping us to actually find out the curves of penetration. Top view has helped us a lot. Side view has helped us to locate the particular prism. After that, what remains is simply the dimensioning, and then our solution will be through. So solution in this case will be the three views along with the curves of penetration. Imagination is not going to help us to the full extent as such. And we will be through with the solution. These are known as the curves of penetration. Visibility plays very important role. dimensions can now be given. It is easy to give the dimensions in this case. For the side of square, we can give the dimension, which is given to us as 40 millimeters. And also for the side of the triangle, which was given to us as 30 millimeters. Heights were not given to us, so we will not be showing those heights. Axis in all cases is getting overlapped. Of course, axis of the triangular prism can be shown in the top view, but doesn't really help us in any manner. In the front view it is getting overlapped. In the side view it is seen as a point. So this will be our first problem of penetration of solid. A hexagonal prism of side 50 millimeters. A hexagonal prism of side 50 millimeters is standing on its base in HP. Is standing on its base in HP with side of base parallel to VP, with side of base parallel to VP. It is completely penetrated. It is completely penetrated by a square prism. By a square prism of side 40 millimeters. Of side 40 millimeters. Whose axis is parallel to both the reference planes. Whose axis is parallel to both the reference planes. And its rectangular faces are equally inclined, and its rectangular faces are equally inclined to HP as well as VP. To HP as well as VP. The distance between the axis, of hexagonal prism and of square prism is 15 millimeters. Is 15 millimeters. And axis of square prism is towards the observer. Axis of square prism is towards the observer. Draw three views showing the curves of penetration. Draw three views showing the curves of penetration. Again, in this case, we will be straight away starting with the hexagonal prism to be drawn, and then once we draw that prism in the front view as well as side view, we will think of drawing that square prism which is penetrating it, So all these lines, they will be initially working as the construction, and for side view we are required to perform the rotation, which is intersection of the vertical line with XY line. That will be the center point for the rotation, and then all these points are to be transferred to obtain the side view. All the points are to be transferred to obtain the side view. So we will be even completing the side view, but again in the construction form. We will mark the center of the axis of the hexagonal prism, and we are given that the square hole. Again, if we want to make a rough sketch for imagination, it will appear like saying that we have the hexagonal prism, say like this. So just a rough sketch. This is a hexagonal prism which will be cut by a square prism, which will be cut by a square prism, and it is going to penetrate through this and will be coming out from the other side. It is going to be some object like this, and we are required to mark these curves of penetration. Whether this edge passes through the hexagon or not, that is to be seen. But then this will appear as a square. Its axis is parallel to VP. VP in this case will be like this, vertical plane, and it is resting on the horizontal plane. So the axis of the square prism will be parallel to VP as well as HP, and this square is making 45 degrees with HP, equally inclined to HP and VP. So in the side view, when you look at it, this square will be seen as equally inclined to HP as well as VP, that is XY line. And it is also said that the axis of the hexagonal prism and the axis of the square prism, they are not intersecting each other, but there is some distance between them which is given to us as 15. So when you go for the side view, this square prism will be having its center 15 mm away from the axis of the hexagonal prism. That too, it is towards the observer. This is the direction in which the observer will be looking at the particular combination. And so we are required to now decide as where the square should be drawn in the side view. And in the side view, for that purpose, we have marked the center from where I am going to measure 15 millimeters as the distance, and it will be the center for the square prism. The side of the square prism is given to us as 40 millimeters. It has to be constructed separately. We can construct it anywhere. So I am constructing the square prism over here of side 40 millimeters. Simply draw a square of side 40 and locate its center, that is join the diagonals. And then you can get the center of the circumscribing circle. Of course, we don't require the full circle also when you reproduce it. So this is to be reproduced. Let us go back to the side view and show the axis of the square prism. The center is to be shown. It has to be shown explicitly. And as we show that particular center, now we can take the distance in the compass, which is equal to half the diagonal, which is equal to half the diagonal, and then we can mark it on the four sides that we have marked. The four corners are to be marked, and so the square can now be reproduced, which we can darken it because that square face will be seen in the side view. And you will find that one corner of that square goes outside the side view that we have already drawn for that hexagonal prism. So this is the square that has been drawn in the side view. And once we complete this part, then we can darken the portion of the side view which is still remaining. So this generator is present only up to the square that is present. This generator is also present only up to the square, then it is cut by the square prism, whereas the generators which are behind, they are not at all cut, and this is how the side view will appear. We have not yet proceeded to the naming part, but these corners are to be taken to the top view. So I am taking these points till the XY line, and then I will have to rotate them to obtain the square prism in the side view, in the top view. So it will be a movement from the side view to the top view with the same point that we have used earlier for the rotation. So all the points are taken to the top view, and then in top view you are required to draw the path for these four generators. Similarly, to get the square prism in the front view, we will be simply drawing the horizontal lines, that is lines parallel to XY, through the four corners of the square. Now let us assume that it is just coming out by 5 millimeters on each side, and so we can show the square face as a full line in front view, and even in the top view the same line can be shown, the same face can be shown. You will have to simply project it down and obtain the corresponding plane in the line view form, but it will be shown like this. Now in top view I can mark all the generators up to the hexagon. In between they will be dotted, but they are present because hexagonal prism is getting penetrated by the square prism. So generators of the hexagonal prism, they will be lost, they will be cut, whereas that of square prism, they will remain intact. And so the top view will show us a few generators of square prism which are going inside the hexagonal prism, and there is one generator which is completely outside. Now let us proceed with the naming, without which the next part will be impossible. So let us name the hexagon as A, B, C, D, E. So it is A, B, C, D, E and F. And so in the front view, this is going to be A dash, this will be B dash as well as F dash. This is going to be C dash and E dash, and this will be D dash. Whereas in the side view, it will be F dash, E dash, then it will be A dash and D dash, and then it will be B dash and C dash. So the naming has been done in the front view, top view as well as side view. Now let us name the square as PQRS. So it is P dash, Q dash, R dash will be the generator towards the observer, and S dash. The same generators can be now named in the top view. This is going to be P dash, then this will be Q dash and S dash, and this will be R dash. Whereas in the front view, this generator will be S dash, this will be P dash as well as R dash, and this will be generator Q dash. So as we complete the naming in the top view, then in the front view, and of course in the side view, it's now time that we should be starting from the top view to locate the curves of penetration in the front view. It will be the same procedure that we have followed in the earlier case. Generator R dash is not at all cut, but generator Q and S are cut by faces CD and faces AB. So those can be taken up. So I am starting with the generator Q and S, and I will be straight away drawing the projectors to mark the points on Q as well as S, and similarly from the other side. It will be a point on Q and point on S. On the similar lines, we can even mark the points on where generator P dash is entering phase AF and DE. This point is going to be very close. It is generator P, point on generator P. So even that point can be marked. So we have marked points on Q, P and S where they are entering into the hexagonal prism. Now let us mark the points where the generator of hexagon, that is generators B dash and C dash, the generators of the hexagonal prism, that is generators B dash and C dash, are cut due to the presence of square prism. So these 2 points should be transferred on generator B and C. So let us draw path through these 2 points and then take that path all the way to the front view. And we are required to mark the points on generator B and C. So we already have generator B dash and C dash with us. So generator C dash will have those 2 points, as well as generator B dash will have those 2 points. So I have taken from the side view the 2 points at which generator B and C are cut. So there will be 2 points each on generator B dash and C dash, and they are now marked on the front view on generator C dash as well as on generator B dash. Now there is one more generator, or rather two more generators, A dash and D dash, which are cut by the square, and then we are required to take the path from each one of them. So path for generators, this time A dash and D dash, and those two paths are again to be taken to the front view all the way to generators A dash and D dash. Those are the extreme generators of the front view. And then we are required to mark those points. So on generator A dash, I will have a point over here and a point over here. Similarly, on generator D dash, I will have a point over here as well as a point at this point. So we have got several points in the front view. Now these are to be connected. For that, let us check the visibility. For visibility, the observer is going to look from this direction. And so first of all, understand that the face BC that we have, that face BC is present up to this level, and that face BC is cut. So ultimately there is going to be generator B present up to this level, generator C present up to this level, and then those 2 points are to be connected. So in front view, we can start with the darkening part, visibility part. So generator C as well as B are present up to this level, and then there will be a line. The same thing will be worked out with the lower portion for generators B and C. And we got the first part related to the visibility. Now anything that will be there on face RS and face QR will be visible. So these 2 points now should be connected to, these 2 points should now be connected to the point on generator S dash and point on generator Q dash. So we also have those 2 points with us, so we can connect them. So this is how it will appear now in the front view. And then from the top view, we will just find out as how we have marked those 2 points. It was Q dash and S dash, those were entering into the hexagonal prism. Even the hexagonal prism, the faces are like this, and as we are looking from the top view direction, looking at the top view in this direction, then these 2 faces will be visible, and obviously those 2 points are visible, and so the generator Q and S, they will be fully present as full lines in the front view till this point, and afterwards they will be dotted. And so let us go back to the front view and show them in the same manner. So generator Q will be present full till the same point which we have over here, and will be coming out through the other part in this way, and in between it is present but will not be seen, so should be shown by the dotted line. This is so far as generator Q is concerned. Same thing is applicable due to the symmetry for generator S. Will be present full till this level, then it enters the hexagonal prism and comes out from the other side, and in between it will be hidden. it will be dotted. So one more part has been completed. Now we will have to consider generator R, which is not at all cut, and it will be shown by a full line in the front view. From left to right it will be seen fully. That is generator R. And generator P is entering the hexagonal prism at this point and coming out from other. So generator P entering at this point and coming out from other at this point. But the in between portion dotted we cannot show because it is overlapped by generator R. And so we will have to simply show the curves. Now what happens is, in the top view we have got a change of the surface, because from visible portion CD we are moving to invisible part, hidden part DE. So the curve till generator D should be visible. But even the square says that, observe the side view, up to Q and S the curve will be visible, which we have already marked. And then portion on PS surface, that is from S point to point on generator A or D, that portion is behind as we are looking from the right hand side direction. So that will be shown by a dotted line. So we will have to first of all mark the dotted line corresponding to that portion. Due to symmetry, it will be present at 4 different places. So this is the portion related to this part or this part which is not visible from right hand side, and then even from that point, that is point on generator A dash D dash, till the point on generator P dash, the portion will not be visible. So even that should be shown by the dotted line. And so the curves of penetration will be now like this. So we have shown the curves of penetration. Now we are required to darken the generators of the hexagonal prism. We have talked about only B dash and C dash. Now let us see how generator A dash will appear. As we are looking from right hand side, we will first see the portion of the square prism, that is from Q dash to S dash. Generator A dash is present till this level, but up to this portion it will be visible. After that it will be behind the square prism as we are looking from right hand side. So this much portion which is present but will not be seen in the front view, and so it can be drawn as a full line up to generator Q dash, and from that point onwards it will be dotted. Similarly, generator D dash is present full till generator Q dash, and after that it will be dotted as long as it is present up to that length. Afterwards it is absent and again will be coming out, but it is behind and the rest of the portion will be visible. Same thing will happen for generator A dash. And so the visibility or the darkness portion of the front view can also be completed. And we get the curves of penetration for the hexagonal prism which is getting penetrated by a square prism with some offset. One of the very typical problem as such. The curves in this case are symmetric axis of the square prism is parallel to HP and VP. Sides or the faces of the square prism are equally inclined to HP and VP. Distance between the square prism and the axis of hexagonal prism, which is given to us as 15 millimeters, that has to be shown explicitly as 15 millimeters. And then what remains is you are required to show the side of the hexagon, which can be easily shown here. It was given to us as 50 millimeters. And then the side of the square is to be shown, which can be taken anywhere and will be shown like this. That is the side of the square prism, which is 40 millimeters. Of course, if you want to show the angle, then even the angle can be shown, as the face is making 45 degrees. So all the information, all the data will be shown, and then it is suggested that generally we should be putting a boundary, not an essential case, not very essential as such. And then we are required to also have the symbol for first angle or third angle. Obviously, as there was a reference of horizontal plane, the problem has been solved by using the first angle technique only. All the constructions are to be retained. Don't eliminate any of the constructions. And this will be the solution of the entire problem.